Assalamu alaikum and very good morning to one and all. In our previous lecture, I was discussing about the engineering mechanics with an introduction. Okay, we have started with an introduction, and I was also giving you the details of history, how it got evolved, how it was used in the 200 BC itself, then how the Newtons, Galileo, Euler and all developed the theory of engineering mechanics. Then we have seen some basic concepts, like we have started with the three basic quantities of engineering mechanics: the length, mass and time. Okay. So these are needed in our analysis. Hope you remember this engineering mechanics course is an analytical course, so in which we have to use problems, we have to solve problems which involve units. If there is no units, your problem results will not be any meaning. Okay, so it will be meaningless. So in order to make your problem complete, you should represent all your results with units. And the basic units are length, mass and time. So for example, if we say force, according to Newton's second law of motion, force equals to m times a. M into a. Okay. M is the mass and a is the acceleration. How will you define acceleration? Acceleration is rate of change of velocity, and velocity is rate of change of displacement, and displacement position difference between the 2 points on which the object is moved, the particle is moved. Okay, the position difference. So if you say position difference, the difference between the positions of a mass or a particle or a body is determined by using the first basic quantity, length. Okay, so length is used to measure the distances. Okay, so you will code it in length. Similarly, if you say acceleration or velocity, there is a time bound, and the distance traveled with respect to some time. Okay, so we have to consider the time. The unit of time is second, so we represent velocity as meters per second, acceleration as meters per second square. Okay. Similarly, mass. So all these basic quantities are independent quantities, independent units which we are going to use on all the dependent units. For example, force is a dependent quantity. Okay, where we consider mass and acceleration, or mass and time. Okay, that is why these basic quantities are described in our previous lecture. And also we have seen the basic laws of engineering mechanics, started from Newton's law of motion, then Newtonian law of gravitation. Okay. And force, if you say, force is a vector because it has got magnitude, direction and sense. Okay. Magnitude, direction and sense. Scalar will have only the magnitude. Scalar will have only the magnitude. Example for scalar, mass or length. Okay. So the force is represented with its magnitude, direction and sense. That is why we have to study in detail about the vectors. In our previous lecture, I have started with the introduction to vector quantity. Okay. The physical quantities, as you see, they are vectors and scalars. And vectors, it has got all the vectors have got all the three: magnitude, direction and sense. And how we can add vectors, how we can subtract vectors, how we can combine two vectors to get the resultant. I have given you example also. A hook pulled by two cables. In order to check whether the hook can withstand the load, we have to find out the net force acting on the hook. So for that, we apply the vector addition concept. We will find out the net force, then we will find out the net stress acting on the hook, From the stress, we will check whether the stress of the hook is within the material's safe stress, then we will say the hook is okay with the load. Okay. So the basic vector concepts are used till we design a component. It is being used till we design a component. That is why this is very important, vector quantity. So this is vector addition. Suppose if we have more than two vector quantities, we will successively add the vectors in pairs, we will get the resultant and we can get the net resultant finally. So that is the procedure which we have discussed in our last class. Okay. Here, so all this parallelogram law, triangular law, we have seen in our previous lecture. I think with the subtraction, we have ended our last lecture class. Now we will see about addition of more than two vectors. If we have three vectors, for example A, B, C, the three vectors are to be added to get the resultant R vector. First, the three vectors are to be drawn with their tails touching each other. Okay. In our engineering mechanics, first we will be dealing with particles. I have told in the introduction class, this is rigid body mechanics. There are deformable body mechanics, solid mechanics, we will be dealing with deformable bodies. Then in fluid mechanics, about fluids. The rigid body mechanics starts with a particle. What is a particle? Anything? Occupies space. So what is the difference between body and particle? Are they same? Can the body be called as particle or particle be called as body?
Body is a collection of particles.
Collection of particles. Good. Okay. Okay. The particle we say is a zero dimension object, where if you in the force point of view, the point of action of force is not important. If there are many forces acting on the particle, the point of action of force is not important in the particle. We assume all the forces are acting at a single point. Or other way we say the forces are concurrent. If the forces are acting at a single point, we call them as concurrent forces. So in the particle, we assume that the forces are acting at a single point, or the distances or where the forces are acting is not important. Size doesn't matter. So we assume it's zero dimension. You would have seen bodies with different dimensions. In your engineering graphics, you would have studied about three-dimensional object. Example for three-dimensional object: solids, any kind of solids. Okay, whether it is solids of revolution or polyhedra type, they are three-dimensional. For two-dimension, planes, lamina or plane. One dimension, lines. Lines are one-dimensional objects. Okay. Similarly, particles are zero dimension. Or in the engineering graphics point of view, can you tell a zero dimension object? Zero dimension object like solids, planes, lines. What would be the zero dimension object? Point. Good. Point is zero dimension. So we consider particles as points. Since points doesn't have any dimension, we also assume that particles doesn't have any dimension, a negligible dimension. We neglect the dimension of the particle. Okay, so we will be dealing with particles. So the forces acting on the body, now we say particles, they will be concurrent. That is why if there are three vectors A, B, C, we are drawing in such a way their tiles are touching each other. Okay, they are concurrent. Their tiles are touching each other. So A, B and the three vectors whose resultant is to be found. So how will you do that? First we will consider the parallelogram between vectors A and B. We will draw a line parallel to vector A from the head of B, then parallel to vector B from the head of A, then we will get the resultant, which is the diagonal of the parallelogram. So we got the first resultant for the first pair. Okay. Now using that resultant and third vector, we will go for the next parallelogram. So this is the resultant R between A and B for the vectors A and B, they are added. Now, this is the line parallel to vector R, R1 otherwise. R1 is the resultant between A and B. So we draw a line from the head of vector C parallel to vector R1. Then another line parallel to vector C. Is it parallel? Okay. Now, from the concurrent point, we have to draw a line considering the parallelogram formed by vectors C and R. Vectors C and R. Okay, so this is the final resultant vector. This is the final resultant vector for the three vectors A, B and C if they are added. And suppose if you want to apply triangular law for the same addition of three vectors, that can also be done. If there are more than two vectors, we draw the vectors like this. Okay, you know the line of action of all the three vectors, the angle. Okay, so you draw it to the scale, some scale you add, vector A, B and C are drawn. Okay, A, B and C are drawn. Then first we consider the triangle formed by vector A and B. So this is the starting point of A, ending point of your B. So this is the first resultant. Resultant 1 formed by the triangle ABR. ABR. Now we consider the triangle formed by R1C and the final resultant. Okay. This is the second triangle and the second resultant or final resultant. But now if you see the procedure, the intermediate R1, it is what you call redundant. There is no need to draw a line between this vector A and B. So we can directly go for the final step. So we draw a polygon instead of a triangle. As there are three vectors, we draw a polygon. Polygon means it more than three. Okay. So we have A, B, C and R, the four vectors which form a polygon. The four vectors if added, they would form a polygon. The closing side of the polygon will be our resultant vector. Closing side of the polygon will be the resultant vector. Okay, so we can directly go for drawing A, B, C with successively with each vector's tail touching the previous vector's head. Like that, to the angle given, and join the starting point and ending point of the last vector, starting point of the first vector and ending point of the last vector, that gives you the resultant. Okay, so this is called, instead of triangle rule, we call it as polygon rule. Okay, we have parallelogram law, triangle law, now we have a polygon law, since we use more than three-sided object. Okay, polygon. So this is about adding three vectors, more than two vectors to get the resultant. Okay. And we may also have to resolve a vector into two components.
Horizontal and vertical.
Yeah, it need not be horizontal or vertical. We will see about it. Okay. So the resolution of vectors is also important. Like we have added the two or three vectors to get the resultant. From the resultant, we have to get the components. Okay, sometimes we may have to do the resolution of the vectors to get the individual components known. Okay, so that is called resolution of vectors. So a vector can be resolved into two components if the line of actions of the two components are known. This can be done by using parallelogram law or even the triangular law. For example, you have R vector whose two components are to be found. A and B are the two components. Say the line of action of vector A and B are given. This is the R vector, line of action of A, line of action of B, the two are given. Now we have to construct the parallelogram from the R vector. We consider the head of the R vector, draw a line parallel to A and parallel to B from the head of the R vector. Okay. Like this, we construct two lines to complete the parallelogram, and now we got the dimension for A and dimension for B. I mean magnitude of A and magnitude of B. Okay. So this is the reverse of what we did in our parallelogram. Okay. A as well as B. Similarly, we can get it using triangle law also, if you know the line of action. From the resultant vector, we draw lines parallel to A. From the tail of vector R, then parallel to B from the head of vector R, you got the triangle. Now, the vectors can be found in order. The direction and sense will be obtained in order. Okay. So this is resolving the resultant vector into two components A and B. And so far we have seen how to get the resultant, how to get the resolution of resultant into two components by using graphical approach. Okay. But the graphical approach may not be accurate. The accuracy depends on how precisely you draw the length, the lines and all, how precisely your instrument is, how accurate your instrument is. So the accuracy may vary. In order to avoid the situation, we can go for numerical method. Okay. In order to get the resultant of two components, or in order to resolve them into resolve the resultant into two components, we use two rules, namely cosine rule and sine rule. Okay, you would have studied it in your school level also by using the trigonometric principle. If there are three sides of triangle A, B and C, and the opposite angles are alpha, beta and gamma, then according to sine law, it will come late. So A by sine alpha equals to B by sine beta equals to C by sine gamma. This is your sine rule. Similarly, cosine law can be used to find out one of the vectors. This say, for example, C vector, if you want to find, this is the square root of A square plus B square minus 2AB cos gamma. Okay. As shown in the triangle, A, B and C are the two sides of the triangle. The opposite angles are alpha, beta and gamma. For example, you have side A, the opposite side is alpha. Side B, the opposite angle is beta. C, gamma. We have to consider the opposite angles. Okay. So this is for finding the numerical solution for our vectors. So you consider the triangles are formed by vectors. Or engineering mechanics, we consider them as forces. As we know, engineering mechanics is completely dealing with forces, the effect of forces acting on the body in rest or motion. So we say vectors, you can imagine them as forces or moments. Okay. Now, any doubt? If not, we will see one problem. We have the same hoop problem which we have solved yesterday using graphical approach. Okay. You have a hoop pulled by two forces F1 and F2. Sorry, the suffixes are changed, but anyway, the two forces F1 and F2. F1 is of 100 Newton, F2 150 Newton. The angle of inclination, the direction, magnitude and sense of the forces are completely given. Okay, you have to find out the resultant of the two forces. So graphical approach which we have seen yesterday. Now we obtain the resultant vector by using your numerical approach. Say this is the cosine law. Using the cosine law, you can find out the resultant vector R of our parallelogram or triangle. Okay. First step is we need to find the unknown angles. Okay. So this angle is 10 degree, this is 15 degree. These are the two vectors, 150 Newton, 100 Newton. In order to get the resultant, first we have to complete the parallelogram. Draw a line parallel to vector 150 Newton F1, then another line parallel to the 100 Newton vector. The two lines will be to give you the diagonal, which is the resultant. So now we have to find out the magnitude and angle of the resultant vector by using our cosine rule and sine rule. For that, first we must get all the included angles of the parallelogram. Since this is 15 degrees and this would be 10 degrees, the remaining angle between the two sides of the parallelogram will be 90 minus 10 plus 15, that is 65. 90 minus 25, 65. So this will be 65. As the opposite angles are same for a parallelogram, this will be 65. And the total included angle in the parallelogram is 360 degree. So 360 minus 65 plus 65 will be 230. So half of the angle will be here, another half will be here. So we consider 230 by 2, which is 115 degrees. So this angle will be 115, this angle will be 115. So we got the angle for this side of this corner of the parallelogram and also the other corner of the parallelogram. All the angles are found. Now we can consider the triangle and apply the laws of cosine and sine. This is 115. This is, we have 32.5. This will be 32.5. We can apply the law of cosine and sine to get your unknown angles. Yes. Now we have to apply your cosine law. R equals to f1 square plus f2 square minus 2f1 f2 cos 115. Okay, we got the resultant vector R equals to 2.26 Newton. So the magnitude of resultant vector is obtained, and in order to find its angle, we go for sine law. Okay, so we consider A over sine alpha equals to B over sine beta equals C over sine gamma. Here A is our force F2, 150 Newton. Okay, similarly the 213 is our resultant R. This opposite angle is sine 115, that is missing, 15 is missing. So we get the answer as sine theta equals to 39.8 degrees. So if you know this is theta, we can find out the phi, resultant angle. Resultant angle can be. Okay. So using the cosine law and sine law, we can numerically obtain the resultant's magnitude as well as direction. Resultant's magnitude as well as direction. Okay? Any doubt? The main part is determining the angle. Okay, if you understand the angle, then you can go for applying the cosine law and sine law to get the unknowns. Now we have another problem. There is a wheel crude wheel which is running along a track. the track exerts a vertical force of 200 Newton on the wheel. We have determined the components of force acting along the axes A and B, which are perpendicular to the sides of the groove. Perpendicular to the sides. This is your groove. So the forces are perpendicular to the sides of the groove. We have to find out components of A and B. Components of A and B. So how will we find out? I said no talking. You don't understand that? Actually, this is your resultant. This is F1, 100 Newton. F2, 150 Newton. Resultant R. This angle you got as 115 degrees. This angle is we need to find. So we use sine law or if its opposite angle is sine 115. This is equals to 150 divided by sine theta. Sine theta. First we find sine theta. Okay. Then we have to find out the other angle. So using this, R already found as 213 from your previous step. From cosine law we found R as 213 or 212.65 divided by sine 115 sine theta. So sine theta can be obtained. Sine theta can be obtained, from which theta can be obtained as 39 point. Sine theta is 0.9063 and theta is sine inverse of that, which is 39.8. So this is this angle. We have to consider resultant angle from x-axis. Okay, that is the angle which we want. We say that is phi. So phi is 90 minus 36.8. That will give you the final answer. We have to find out the magnitude of R as well as the direction of R. The magnitude of R we got it as 213 from our previous step. Now the phi is the angle of resultant R. If you see the previous figure, you have two angles. This is theta. Theta is the angle between the two sides of our triangle. Okay, angle between F and R, included angle between F and R. Whereas we need to find the phi. We need to find the phi, which is the angle made by the resultant with our x-axis. Okay, that is what we have to give finally. That can be obtained by considering 90 total angle and subtracting to.
Sir, 36.8 plus 15 only.
36.8
plus 15 none of that.
32.5.
36.8 plus 15.
32.5 plus 15. We have a V-grooved wheel running on a track. Okay, we have to find out the components. So we consider this is our resultant given. Okay, 200 Newton. We need to find out forces acting on. Say this is FA. FP and FA. So if you follow the graphical approach, we can draw 200 Newton line to some scale. Then you know the line of action of A and B. So from the head, we draw a line parallel to this and as well as parallel to the other vector. We got the parallelogram. So now we got the magnitude of forces FA and FB. If you follow the graphical approach. This angle is given as 30 degrees. This angle is given as 30 degrees. If we want to apply our numerical approach, then we have to consider the triangle. So this is 30 degrees. This will also be 30 degrees. And this is 180 minus 60, 120 degrees. 120 degrees. So we got resultant R, FB, FA. Okay. So consider the sine rule. A by sine 30 will be equal to the resultant by sine 120. You can find out A as well as B. The same value. Okay. Resolution of forces can be obtained by considering either graphical approach or by using sine law and cosine law. Okay? Any doubt in this problem? The final answer, I think, is around 115 Newton. Yeah, the A vector or B vector equals to 115. Yes. Now we are given two forces FA and FB. The angles of both the forces are given as per the problem. If theta is 60, we have to find out the resultant. So this is 60 degrees, this is 40 degrees, and we have to find out the direction and magnitude of resultant. That means the resultant did not pass through X. Resultant force does not pass through X. Okay. We assume, we try to solve the problem by assuming it passing through X. No, it's wrong. Okay. So now we have to construct the parallelogram and find out the angles. This is 60 degrees for FA. This is 40 degrees for FB. This is 40. So you draw lines parallel to the corresponding forces. You will have the resultant. Okay. This angle, what would be this angle? This is 60.
30, 50.
So it will be, need not be 30, 50. If it is 30, 50, that means you are assuming it passing through X. It need not be 30, 50. Of course 80. Okay, this is 80. Since in the parallelogram, the opposite side of this angle will also be 80. Opposite angle will also be 80. Now we have two remaining perpendicularly opposite angles. So for that, 360 minus 80 plus 80, 160. So 200. The 200 you have to split into two, assuming they are acting in the opposite side. So if this is, here you have 100, here you have. Okay, so now you got the angles of the parallelogram. Either you consider cosine rule or sine rule, you can solve it. Okay, considering cosine rule, you will have This 100, F1 FA square plus FP square minus 2 FA FP cos 100 will be your resultant. You can find out the magnitude, then the angle can be found by using sine rule. Okay, FA by what is the sine 40? R by sine 100. So you can find out R you have found already from the cosine rule. Sorry. How will you find that? R by sine theta.
What is 900? 900.
Okay. So either use cosine rule or sine rule to get the line. And also calculate theta for R with respect to x. This is the force. This is the force. We have to resolve it into two components. The line of action of the resolved component is not given, but anyway we have to find out. So in that case, we can resolve it along x and y. Okay, this is one approach. The other approach is we have to find out resultant of many forces, not 1, 2 or 3. Okay, if there are many forces, it will be difficult to consider parallelogram law and sine law in each pair and proceed. Okay, so for that, we resolve each force into horizontal and vertical components or parallel to x and y axis. If x and y are the specific axis, okay, x and y are the specific axis. So this is applied and the forces are coplanar. The forces are coplanar. What do you mean by coplanar? They act in a single plane. The forces are acting in a single plane. So if they are coplanar forces, we can follow the concept of using specific axis. Specific axis. So this force F, we resolve it into two components like this. Fx and Fy. Okay, Fx force Fx and Fy. And we apply another concept called unit vector, Cartesian vector approach. Okay, that is another approach where we consider a unit vector which is acting along x and y. So this is unit vector acting along x, acting along y. If this is the force F, we resolve it into two components whose scalar is given as Fx and Fy and it is multiplied by I. Okay, so we did not change the vector significance. This is F, we write it as Fx I unit vector. Okay, unit vector is dimension, it has got a unity, no dimension, dimensionless vector. Okay. So this Fx and Fy are scalar. They are scalar. They have only magnitude, whereas I and j are the unit vectors. So the vector addition principle is not altered, but we make the process simple by considering the unit vector concept. Okay, unit vector approach. Now we will see one case. Suppose if you know the angle theta, the Fx and Fy. Okay, the x component. So this is your y component, this is your x component. You write it as Fx, opposite side is adjacent side. So your x cos theta, your y component will be sin theta. Okay. This the fx and fy can be resolved in two components acting along x and y. So x component is x cos theta, adjacent side. Y component is fy sin theta. Okay. Sorry, this f cos theta and f sin theta. You consider only the magnitude. F cos theta and f sin theta. So the scalar for unit vector are obtained, and we can, okay, suppose if there are multiple forces, say three forces are acting, F1, F2, F3. Consider three forces acting here. F1, F2, F3. The angles are given, theta 1. Okay. Now we resolve each forces into two components like this. Yeah, you write F1x, F1y, okay, F2x, F2y, like that is split. F3x, F3y. And F1x is F1 cos theta 1. F1 cos theta 1. Yes? Similarly, F1y will be F1 sin theta 1. Okay, like that we find out the scalars for each component, then finally we sum up. The resultant acting along x will be sigma fx. This is sigma fy. So the resultant vector can be written as R equals to Rxi plus Ryj, unit vector. Rxi plus Ryj. Okay. So this will be applicable if there are more number of forces. For example, we will solve one problem now, and with that, a hook pulled by three cables. We have three forces, F1 150 Newton, F2 50 Newton, and F3 110 Newton. The angles are given. This makes 30 degrees with x-axis. This is 20 degrees. And this would be 15 degrees. Okay, the direction, sense and magnitude of the three vectors are given. We have to find out the resultant. Okay, we have to find out the resultant. Suppose if you go for parallelogram law, we have to consider each pair, or triangular, we have to consider each pair, and we proceed. Graphically we will find out, or if we have to use trigonometric principles. Instead, we go for vector algebra. Okay. So now we consider each force at a time. We will get the x and y component in order to make you easily understand it. force F1, it makes 30 degrees with x-axis. So we resolve into two components parallel to x and y. Okay. So how will you resolve? So this is your x component, this will be your y component. X component and y component for force F1. Force F1. Okay. So I write F1x. F1x is 150. Okay. Cos 30. Since x is in the adjacent side of this triangle, x is in the adjacent side of the triangle, I have to consider cos 30 degrees. Similarly, F1y will be 150 sin 30. 150 sin 30. This is for F1. If we consider F2, F2 is acting 20 degrees to vertical. Okay, 20 degrees to vertical. I resolve into two components as like this. This is your Fy, this is your Fx. Fy and Fx. So your F2x. So what will be your F2x? 50%.
F2 sin.
F2y. Cos 20, correct? Is it correct?
No, sir.
Why not? Your x component is in the opposite side, not in the adjacent side. Okay? So you cannot mug up, you cannot just remember it and you cannot write. You have to consider the triangle is turned 90 degrees now. So your opposite side is x. So this should be F2 sin 20. Okay, and this will be adjacent side cos 20. Okay. Similarly, if you consider F3, F3 is acting like this, 15 degrees. So resolve into two components. Fy, Fx, F3x. Okay? Is it correct? Any wrong in this? Any wrong in it? Yeah, if you see Fx, it's okay. Okay, both the components are in the positive axis. Fx is acting like this, Fy is right side of your x-axis is positive, upside of your y-axis is positive. So both the components are positive components. Whereas if you see, if you come to F2, your y is positive, x is in the negative axis. So we have to add minus F2 sin 20. Minus F2 sin 20. Similarly, in the third one, both are negative. Both are negative. Yeah. X is positive. Here, x is like this. So now we have to add all the x components, all the y components. You will get the resultant x, y components. We can find out the resultant. Now you can apply Pythagoras theorem. Okay. So I develop a table, forces, their magnitude, Okay, so we have four forces, F1, F2, F3, 150. Okay, three force magnitudes I have written. X and Y components are already calculated. I can write them. It's 129.9 minus 27.4 and 96. This is 75.2. Now we have to sum up. Find out sigma fx, sigma fy. Then resultant you can use by applying Pythagoras theorem. Say you have the resultant all acting like this. This is the scalar of y component, scalar of x component. So you can write it as sigma fx square plus sigma y square. Root will be your r. Similarly, you can find out the angle made in the resultant as sigma fy by sigma fx. Okay, so this fx, fy are scalars. Okay, so you have to consider that and find out the angle made by. Okay, so you can find out theta, the magnitude as well as direction of r. Okay, so this approach is called vector algebraic approach. Okay, you consider unit vector, resolve them into two components along x and y. The x and y need not be horizontal and vertical. You can even tilt it to any angle, but the x and y remains perpendicular. The x-y axis, they remain perpendicular. Okay, but they need not remain horizontal and vertical. So in today's class, we have seen how to resolve the forces into two components and how to add them numerically. Numerical approach of adding the two vectors, two forces or more than two forces by using cosine law and sine law also we have seen. Okay, and the unit vector approach. So tomorrow, next class, we will see the Cartesian vector in space, the forces in space and equilibrium of the particle. Okay.